Hello folks, this is a dashboard clock for a Morris 8 and it's made, I believe it says under there, Smith. Apparently it doesn't work. We've got a little knobby on the back of it here, and if we push that spring-loaded knobby in, we can adjust the time on the clock face. Let's get inside this thing and let's figure out what the deal is. Now apparently, and I don't know if you can see that very well, but it says 6 volts on the top of it here, and Pete also tells me that the Morris 8 is a 6 volt car. So yeah, he's asked me to look at this and see if we can repair it, and if we can't repair it, then maybe we can consider putting a quartz mechanism inside here instead and making it look just as good. Yeah, I don't know what to expect to find in here. I mean, clearly it's not going to be a Japanese quartz movement. You know, I mean, really and truly, what is going to be? Hang on, here we go then. So we've released, so we've released the mechanism. You can see that because now the mechanism moves backwards and forwards on the front fascia. So I'm wondering if, when we undo these 2 screws on the front fascia, if the whole clock body will come away from the clock mechanism. I guess we're going to find out any moment now. But apparently these things are as rare as rocking horse poop. And I haven't seen much rocking horse poop anywhere. Right, there we go. Let's keep going. Boom! We've got a coil here. We have, oh my goodness, it looks like we've got a spring and a flywheel and magnets. I think the coil must run AC somehow, and I think that will, there we go. Can you see at the top there? You can see the little flywheel rotating backwards and forwards. Oh wow, it actually looks and sounds like it'll work. Let's see if we can find a 6 volt power supply. So I've found my benchtop power supply here, my little homebrew benchtop power supply. So let's get that down to a 6 volt output. And that is it, near as damn it, 6 volts on the dial, on the button. And let's connect this up and see what happens. I wonder if someone has connected 12 volts to it or something silly like that. Anyway, let's connect 6 volts to it, what it should be. And this certainly looks like it's the positive pin, and this certainly looks like it's the negative. Everything's connected up. Nothing's happening, as Pete says. Oh, we can see the mechanism trying to run. It is wibbling backwards and forwards. Clearly, when you put it this way up, the amount of friction that is on this wheel will be much smaller. Just really keen to get this working for it. But that flywheel is now working nicely. So it looks as though the friction at this end of the flywheel is fine, but when the clock is turned up the other way, it looks as though the friction is a little bit too stiff. I wonder. I do want to get into this, but I'm really nervous about breaking it. All of the components in here are so fine. I'm just not a watchmaker. I'm not a clockmaker. I'm going to get my magnifying glass out and I'm going to have a little bit more of a look into this to see what is going on. If you look very carefully at this cog here, you can see that there's quite a lot of rubbish on it. And it appears as though that rubbish is just causing a bit of a jam. So I'm going to get a paintbrush. I'm going to get in there and I'm going to try and remove some of that rubbish with the paintbrush. It looks like it's just debris that's stuck in the cogs in the clog. With a bit of luck, that will solve our problem. Thanks to my street lamp, or what I call the sun, I've been able to have a really good look at what is going on inside this device. And some compressed air, gentle compressed air, and a little bend of an electrical connector has definitely fixed this. This thing is running now happily at 6 volts. So let me try and explain how it works to you. First things first, I noticed that this jewel here, in fact this entire assembly, would move backwards and forwards. Clearly the jewel, or perhaps the posts, the rod, or the jewels, more likely the metal rod that touches the jewel at the front here and the jewel at the back here. And in fact, if you look, you can just about see a little red jewel just there. So what I had to do was just ever so slightly lap underneath these two pillars. Just used a little bit of emery cloth just to bring those pillars down ever so slightly and make better contact with those two jewels. Not too much. And the good news is that now has almost no play in it. It's got just a tiny bit of lateral play in it, or vertical from this perspective, lateral from that perspective. Yeah, that is now fixed. So the way this works, we've got on the back of here a coil, a big coil of wire, and it's a DC coil. And then what we've got here, if you look and see this iron bar that comes out, and actually if you see down inside here, so if you look down inside there, you can see the flywheel that I'm rotating with my finger lines up with that iron bar, and that iron bar magnetizes when the coil magnetizes. Now, clearly, if the coil was just to magnetize all the time, that iron bar would sit in one position. There's also another iron bar on this side of the coil, and effectively creates a horseshoe magnet sort of effect between the two iron keepers here on the flywheel. So that's the way that works. Now, as I said, if you magnetize this coil permanently, the magnetic field will be permanent, which means that the flywheel will just sit in one place and it won't rotate backwards and forwards. If you look just here, you'll see a little tiny, I'll just poke it gently, you'll see a sprung-loaded contact, and also on the bottom of the flywheel you will see another contact, and hopefully you can see that bar brushes past the other contact. And what that does is it turns the coil on and off. So when you connect power to this, the coil turns on and off, effectively operating in an AC type of format. So the coil pulses, and as the coil pulses, it attracts the magnets. As soon as the magnets are attracted to it, it disconnects. The magnets are then sprung loaded. That entire flywheel assembly here is a sprung loaded with this very fine spring on the top here, and that keeps the flywheel moving backwards and forwards. And then what happens is we've got a little cog combination here, and this cog combination just continues to rotate the dial on the front of the clock. So it's a Smith's or a Smith electric clock, and Smith were a company that used to make dials and indicators for many old English cars. So yeah, that has been really quite a good fun project, getting this back up and running, and I'm sure Pete will be super happy to see it, to have it working, and actually putting it back in his restored Morris 8 that he's working on at the moment. In my head, I thought to myself, this clock looks like it could be a bit power hungry. So I've switched to DC current clamp. We'll just zero the current clamp, and let's have a look. Hopefully you can see that. It's between sort of 7 and 10 milliamps. This clock is not going to flatten your 6-volt Morris 8 battery very quickly. As always, thanks ever so much for watching Dubious Engineering. Take care, have a fabulous week and weekend. Don't forget to give us a good old thumbs up, and we'll see you in the next video. Cheers and bits, people. Bye for now.